This is project 1. The first two blocks we're going to test are the OR3 blocks, inputs being the first three switches, and output of the equation block is LED 9, and output of the behavioral block is LED 8. Next is an XOR 2. Inputs are the first two switches, and output is LED 7. Next is the NOR 5 and NOR 5 component blocks. NOR 5 is LED 6, NOR 5 component is LED 5, and the inputs are the first 5 switches. Next is a 4-bit OR 3, so that comes out to be 12 inputs. So this is all the switches, and then two of these buttons. The buttons are active low, and the LED output is LED R4. So with all these switches low, we have two buttons that are high. If we make both of those low and everything else is low, and of course we have a 0, and anything else turns it on. Next is the 3-bit full adder and the component 3-bit full adder. So the 6 inputs to both of these are the first 6 switches, and then the 7th one is a carry-in. So if we just turn on the carry-in, we can see where the bits start. So that's the least significant bit for the 3-bit full adder, and that's the least significant bit for the component 3-bit adder. So if we do 1 plus 1, we get 2. If we do 2 plus 4, we get 6. No, is that 7? I see, it's 7 because I got this guy on. So 2 plus 4 equals 4 plus 2 is 6. So those work. And our output is only 4 bits, so if I do 4 plus 4, we do get 8 at LED 3 and LED green 7. Lastly, we have the 3-bit full adder behavior model. I used buses, and so the switches got kind of weird, but our most significant bit of A is here, least significant bit of A, and then most significant bit of B, least significant bit of B. So if we do 1 plus 1, and our output is LED 3, 2, and 1, so that's 2. And then if we do 2 plus 1, we get 3. And then if we do 4 plus 1, we get 5. And then of course, there is no overflow LED, so nothing happens. We just have zeros, but we do have overflow.